This is Present Tutoring and Advising. Today we're going to be talking about the types of chemical reactions. There's 5 major types you should know about, which include synthesis, decomposition, single replacement, double replacement, and combustion. So starting off with synthesis reactions, we're basically looking at reactions where two or more substances combine to produce a single product. So let's say that you have A, which is maybe a compound or an element, and then B, those two will combine to make one product. An example of that would be two elements reacting with each other, like iron, just Fe plus Cl2 chloride or chlorine, and then those react to produce FeCl3. Another one would be two compounds reacting like calcium oxide and water combining to make calcium hydroxide. If we were to kind of think about it, we can think of a synthesis reaction as happening between two elements or two compounds or two or more of those, or it could even be a reaction between a compound and an element. Decomposition reactions. This is basically the opposite of a synthesis reaction. You start off with, one compound, and then that compound breaks apart to produce two or more elements or new compounds. Some examples of this would be the opposite of the previous reaction that we talked about, where we produce calcium hydroxide. So now calcium hydroxide is breaking down to produce calcium oxide and water. And then another thing that happens with decomposition is that it usually is driven by some input of energy. So it's either you like apply heat to the system or apply electrical current to the system. But yeah, in this case, we have aluminium oxide breaking apart to produce aluminium and oxygen. And then you also have single replacement reactions, where basically the atom of one element replaces the atom of another element in the compound, thereby displacing it from that compound. So that's why we can call it a single replacement reaction, or we can call it a single displacement reaction. So in this scenario, you have A plus BX, and then notice how A displaces B from BX, and then it becomes AX plus B. A sample of this would be potassium reacting with sodium chloride, and then you end up producing potassium chloride and sodium. And this type of reaction is usually driven by the fact that one element is more reactive than the other element and so can displace that element out. So in this case, potassium is more reactive than sodium, and so potassium can kick out sodium and then produce potassium chloride, and then the sodium can be on its own. And then, yeah, and then you also have your double replacement reactions, which are also called double displacement reactions, where you have an exchange of anions and cations. So in this case, the anions are usually the negatively charged ions in the compound, and then the cations are the positively charged ions in the compounds. So most of the time, we usually would write the cations, the positively charged ion, before we write the negatively charged ion in a compound. So in this case with AC, A is positively charged, C is negatively charged, B is positively charged, D is negatively charged. And so we have a scenario where the positively charged A can then go and combine with the negatively charged D from the other compound, and then the positively charged B can go and react with the negatively charged C. And then that's why you're having like a switch of different anion cation combinations. So we actually do ask ourselves, what is it going to take for us to have a successful double displacement reaction? Usually, double displacement reactions or double replacement reactions are usually successful when you either produce a precipitate, which is a solid, when you produce a gas, or when you produce water. So in the first scenario, you have sodium nitrate reacting with, or sorry, you have silver nitrate reacting with sodium chloride, and then those cross react and produce sodium nitrate and silver chloride, and silver chloride is a solid. So this is a successful double replacement reaction. And then you could also have a scenario of potassium cyanide reacting with HBr, and then it ends up cross reacting, and then you produce KBr and HCN. And the reason why this would be successful is because HCN in this scenario would be gas. And then you could also have HCl reacting with sodium hydroxide. It produces NaCl and water. Because this is an acid-base neutralization reaction, the water being produced will tell us that this will indeed be a successful reaction. Okay, Now, you might be asking yourself, in these double replacement reactions, when I cross react the two ionic compounds, will a precipitate form? Well, it really does depend on the solubility rules, and I'll make a separate video on this. But generally, we have rules to follow for an ionic compound. For example, most compounds that, or basically all the compounds that are nitrates, none of them are insoluble. All of them are soluble. So if you produce a nitrate and they ask, is this precipitate going to form? You would say no because all nitrates are soluble. All acetates are also soluble, and then our chlorides tend to be soluble with the exception of silver chloride, mercury chloride, and lead chloride. And so these are exceptions to note. And then you could also have compounds like sulfides. So these are these are ionic compounds that are typically insoluble. And so this is a case of like when you're looking at S2 minus in a compound, they generally are insoluble with the exception of compounds that contain the ion NH4, alkaline metals, and such. So whenever you're thinking about whether a compound will or will not produce a precipitate, all you need to do is refer back to your solubility guidelines, and it's typically organized into a chart, and you should be able to determine whether a precipitate forms or not. And in the scenario of a double replacement reaction, if a precipitate indeed forms, then you'll be able to tell that the double displacement reaction would actually move forward, it will be successful. Okay, and then finally, we're talking about combustion reactions. So, a combustion reaction is basically a reaction where oxygen will react with a substance, and then energy is often released on the product side in the form of heat and light, or light. And so, here is an example of a combustion reaction where you have a hydrocarbon. A hydrocarbon is a compound that's solely composed of carbon and hydrogen. It reacts with oxygen, and then here we're producing carbon dioxide, water, and energy. So it does fit the requirements for a combustion reaction where you have an oxygen reaction or a reaction of oxygen with a substance to produce energy. Here's another scenario. What happens when coal is burned? So coal is organic material that's mostly composed of carbon. When carbon reacts with oxygen, it ends up producing carbon dioxide and water, or sorry, carbon dioxide and energy. And I also want you to notice how the reaction of carbon with oxygen is also a synthesis reaction. This is to tell you that most reactions are not cut and dry. You can have a reaction that's a combustion reaction, and it could also double as a synthesis reaction. And then what happens when a hydrocarbon is burned? So we see the template for hydrocarbon combustion at the top of the slide, but then just here is like an example, a specific example using CH4, which is methane, reacting with oxygen, and it produces carbon dioxide, H2O, and energy. When it comes to these combustion reactions, it's super important for you to balance the reactions to make sure you have the same number of elements on both sides. So that summarizes all the different types of compounds. Thank you for your time. If you are interested or have any questions, please email presenttutoring@gmail.com. And then I will also be linking a free consultation link in the bio. And in general, we offer STEM tutoring. We also offer school application support. So whether you're applying to grad school or college, we can support you with making your materials or editing them. And then we could also support you with job applications. So in terms of like resume, personal statement, cover letter support, we are here for you. Thank you once again, and stay tuned for the next video.